Today we'll be looking at graph of logarithm function. So as you can see, we have two graphs, the red one and the blue one. So this is a graph of logarithm function. So let's say y equal to the red one. Okay, let me use red. This is y equal to log a x. That's the base is a. Y the blue one. Okay, let's finish up. They are the same, but there is a condition where a must be greater than 1. So the base here must be a number greater than 1. Why the blue graph is also y equal to log a, that's base ax. But in this case, a must be a number between 1 and 0. So that's the difference. And looking at the graph, you see that they both intersected at 1. So that's one of the characteristics of a logarithm graph, the parent logarithm graph. Here, the coordinate is always 1, 0. So that's a very important point. That's why it's here. So, because from our laws of logarithm, if x is 1, log any base to 1 is 0. So that's it. So let's now look at this question. So look at this. We ask attach the following function to the given graph. So if you have more than one graph plotted using the same axis, we have two aspects of graph here. We have two aspects of graph. The one with where that is this 3, 1, 2, 3 is where a is between 0 and 1. Why this is where a is greater than 1. So you can see this are all up here. Why this? But the problem now, which one should be higher and which one should be lower? So the nearer to the x-axis, the larger the base. So I'm saying that this is y equal to log. Which base is which of them? 6. So this is the base 6. Why this is y equal to log base 3. Why this is y equal to base 2. So the nearer to the x-axis, the larger the base for this. Y here the nearer, the smaller the base. Yes. That's from here. Among have 1 over 3 and 1 over 6. Which one is the least? 1 over 6. So I have y equal to log 1 over 6x. Why this is y equal to log 1 over 3x. Finally, this is y equal to log half x. Yes. So that's it. So let's move to another one. So we ask find this gs by transforming fx. Find the coordinate of f. So there is what we call graph transformation. So if you have a function, let me use log function, maybe y equal to fx. This is the intercept 1. If I multiply x by minus 1, so this function is now y equal to f of minus x. So whenever you multiply the x by negative, it will be reflected about the y-axis. So that's it. And also there is what we call shifting, horizontal and vertical shift. So if you have a function fx, and you now have plus or minus 8, plus or minus a plus f of x plus or minus b. So note that this original function, to get the second one, you need to shift the first one a unit, either up or down. So this a means vertical shift, while the b means horizontal shift. And the shifting could be left or right for horizontal, or up and down for vertical. So if it's negative, it's down. If you move down, while if it's positive, is up. Why here, if it's positive, you move left. Negative, you move right. So that's what we are going to use to solve this. So look at this second diagram. That's part of the solution. This fx, I know this is the intercept 1. If I multiply by negative x, is now minus 1 here. So we'll get this graph. So h of x is f minus x. And this is a good point, very important point on this graph. For this blue one, this is the point because they're on the grid line, the major grid line. This is also for this. So if I move 1, 2, 3 to the right, so I will now get the blue graph. If I move hx, this, so you see that, remember, if hx is this, so we now have f minus x plus 3. Yes. You'll be surprised, why is it 3 plus 3, not minus 3? Because if you look at this, you can write minus x plus 3 as minus x minus 3. Do you see it? The negative here, outside here, means the reflection about the y-axis. So that's why it's minus x plus 3. So do you see it? And the problem now, we need to get the actual, this is just shifting, but we need to get the actual logarithm graph. So I'm saying that, remember, fx is a log graph, which is log ax. Yes. So fx is log ax. So we need to get a, the base, because we are given some points hidden that, because we are given some points on this graph. Look at it. This is a good point. Yes, it's on the major grid line. We've used this. So look at this. So what do you notice? This is 3 and this is 1. So we now see at x3, y1, because we want to get the actual value of the function, log function. We have 1 is equal to log a, log base a3. So which implies that a must be 3. So we've known the value of a. So we now have that fx is log 3x. Therefore, g of x will now be log 3 minus x plus 3. Yes. So that's it. Very important. So, but we're asked to find the point of intersection. That is the coordinate of f. So at f, g of x must be equal to f of x. So the two must be equal. So I have that log 3 minus x plus log base 3 minus x plus 3 must be equal to log 3x. Yes, log base 3x. You can see we have two log functions with the same base. Log base 3. So the numbers must be the same. Minus x plus 3 must be equal to x for the two to be equal. So we have 2x, that's x plus x, 2x. We are left with 3 here. Therefore, x is 3 over 2. So the value of x is 3 over 2. So to get the corresponding value of y, we choose either fx or gs and substitute the value of x so that we'll get the value of y. But we have to get the coordinates. So let's choose fx. So since fx is log base 3x, and we've known that x is 3 over 2. And from our law of logarithm, this means log 3 minus log 3 2. And log 3 is 1. 1 minus log 3 2. So that's the value of y. Our y value, which is fx, is that. Therefore, the coordinates of f, coordinate of f is 3 over 2, 1 minus log. So that's our answer. That's the coordinate.